We are going to continue with this lesson, complete the second half. So our objective remains the same. I can apply theorems about isosceles and equilateral triangles to solve problems, but this time the focus is going to be on equilateral triangles. So keep in mind, an equilateral triangle, all the sides are congruent, and if all the sides are congruent, all the angles will also be congruent. With the equilateral triangle theorem, given that we have a triangle ABC, if AB is congruent to BC and BC is congruent to AC, then angle A is going to be congruent to angle B, and angle B is also going to be congruent to angle C. The converse is also true. If angle A is congruent to angle B and angle B is congruent to angle C, then all three angles are congruent. Then that means that all three sides, AB would be congruent to BC, and that would be congruent to AC. Prove that equilateral triangles are equiangular. What rotation can be used to show that angles of an equilateral triangle are congruent? Sketch an equilateral triangle. I know the angles. I know that the sides would be congruent. So what rotations can I use? Find the center of your triangle. That's centered, let's call it point D, has to be the same distance away from points A, B, and C. So it must be the center of the triangle. Find the degrees of rotation. I know that a full rotation is 360 degrees. To get angle C onto angle B, I would have to rotate it a third of 360. So 360 divided by 3 is 120 degrees. That means a rotation of 120 degrees centered on point D would make this triangle overlap or map onto itself, and therefore we know that angle C is congruent to angle B. We can also rotate it again, so 120 twice would be 240 degrees. And if we rotate it 240 degrees centered on D, we can also see that angle C is congruent to angle A. We're going to be solving problems that use the angles in isosceles and equilateral triangles. From this diagram, we can see that this is an equilateral triangle. If this is an equilateral triangle, then the angles are going to be congruent. Go ahead and mark the triangle. I know the angles would be congruent. I know the angles inside of a triangle add up to 180. There's three congruent angles. So 180 divided by 3 is equal to 60. So each one of these angles measures 60 degrees. When we look at triangle PNO, we see that this triangle is an isosceles triangle. Two of the sides are congruent. So if the sides are congruent, the base angles will also be congruent. First question. Find the measurement of angle PNO. PNO. We're looking at this measurement. We know that this is going to be a linear pair. So if I need to find this measurement here, then the measurement of angle PNO plus 60 degrees is going to be equal to 180. And once again, this is because we're working with a linear pair. Solve for the measurement of angle PNO. Okay, we subtract 60 from both sides, and we end up with the measurement of angle P and O is equal to 120 degrees. So I'm going to go ahead and put that in here. For question B, find the measurement of angle NOP. So it goes from N to O to P. They want me to find the measurement of the base angles. We are going to use the triangle sum theorem. I know that the angles inside of a triangle add up to 180. So the measurement of angle NOP plus the measurement of angle OPN plus the 120 would be equal to 180 degrees. These two measurements are the same. So I can rewrite it as 2 times the measurement of angle NOP plus 120 is equal to 180. So just remember that the measurement of angle NOP is equal to the measurement of angle OPN. Solve for the measurement of angle NOP. Okay, so we need to subtract 120 from both sides, and that leaves us with twice the value, 2 times the value of the measurement of angle NOP is equal to 60. Divide both sides by 2, and we have the measurement of angle NOP is equal to 30 degrees. Habits of mind. How do you know what the measures of an angle of an equilateral triangle are? The triangle sum theorem states that the sum of the interior angles in a triangle add up to 180 degrees. So if we get those 180 degrees and divide it by 3, each interior angle in a triangle, in an equilateral triangle, would be equal to 60 degrees. Do you understand? How are the side lengths and angle measures related in isosceles triangles and in equilateral triangles? Okay, we know that in an isosceles triangle, 2 sides would be congruent, and the angles opposite to those sides would also be congruent. The non-congruent side that's in between the congruent angles is known as the base, and these are the legs. With the equilateral triangle, all the sides are congruent and all the angles are congruent. Error analysis. Nate drew the following diagram to represent an isosceles triangle, sharing a side with an equilateral triangle. What mistakes did Nate make? There are 2 ways that you can analyze this problem. I know that in an equilateral triangle, all the angles inside of an equilateral triangle add up to 60 degrees. This is an exterior angle, and I know that if I use the exterior angle theorem, that exterior angle is equal to the sum of the two furthest angles. And in this case, that's not true. We can also look at this as this being a linear pair. I know that a linear pair adds up to 180, and if I do 60 plus 140, that's equal to 200, which is not 180. So this is also not true. When Nate drew the triangle, this angle should measure 120 degrees. making these angles 30 degrees each. What is the difference between the base and a leg in an isosceles triangle? Okay, the legs are going to be congruent, and the base will always be located in between the congruent angles. Reason. Is it possible for the vertex in an isosceles triangle to be a right angle? Explain why or why not, and state the angle measures of the triangle if possible. The answer is yes. Starting with a right angle, we can make sure that these two sides are congruent, and we know that this is going to be a 90-degree angle. If we connect the two legs, we know that these measurements would end up being the same, and they would have to be equal to 90. So 90 divided by 2 gives me 45 degrees. So each one of the angles would measure 45 degrees. Communicate precisely. Describe 5 rigid motions that map equilateral triangle PQR onto itself. We can do a reflection using a line that goes from point P to the midpoint of QR. And we can do the same thing going from any of the midpoints to one of the vertex. So that would give me 3 different lines of reflection. Using the center point, we can also use or do a rotation using the center of the triangle as a point of rotation. And rotate clockwise 120 degrees and 240 degrees. Do you know how? For problems 6 and 7, you're going to find the measurements of all the angles. So find the measurement of angle A, B, and C. The measurement of angle D, E, and F. For problem 6, we have an isosceles triangle. If the sides are congruent, the opposite angles are congruent. So that means that angle C is congruent to angle B, so angle B is also 69. And I know that the angles inside of a triangle add up to 180. So you would do 180 minus twice the value of 69, and that would give you the measurement of angle A, which is 42 degrees. For problem 7, once again, isosceles triangle. Base angles would be congruent. So straight opposite from the congruent angles from the congruent sides, we have the congruent angles. If angle E is 77 degrees, then you would say 180 minus 77 and divide that value by 2. And that would give you the measurements of angle D and E, which is 51.5 degrees. Okay, for problems 8 and 9, you're going to be finding the lengths. Find the lengths of all three sides. Here we have our base angles. They're congruent, so the sides opposite would be congruent. You would have to start by writing down an equation. I know that 3x plus 8 is equal to 35. Find the value of x. Then you're going to be plugging it back in, and that would allow you to find the measurements of all of these sides. GH and GJ. Subtract 8 from both sides. Give myself some space. That leaves you with 3x is equal to 27. Divide both sides by 3. X is equal to 9. Now that we have that value, all we have to do is plug it in. So you would have 3 times 9 plus 8 for side GH, GJ, and side GJ would be equal also to 35. We didn't even have to plug it in. Do the same thing for our side GH. That gives you 49. Okay, we're doing the same thing with problem 9. We have the base angles. They're congruent. The sides opposite would be congruent. I know that side LK is 26. That means that side LM also has to be 26. Since those two sides are congruent, I can make my equation. 2y plus 8 is equal to 26. Solve for y, plug it in place of y so that you can find the value of km. Take away 8 from both sides. 2y is equal to 18. Divide both sides by 2, and y is equal to 9. Plug it in. 3 times 9 minus 7. So that means that km is equal to 20. What is the measurement of angle ABD? ABD. We know that this is an isosceles triangle. Base angles would be congruent. And if these angles are going to be congruent, that means that this is a perpendicular bisector. So that's going to measure 90 degrees. So I know that 90 degrees plus 71 would give me the measurement plus the measurement of angle ABD would give me 180 degrees. Combine your like terms. Subtract 161 from both sides. And the measurement of angle ABD is equal to 19. A light is attached to a cable and suspended between two poles that are 9.5 feet tall. How far above the ground is the light? Round your answer to the nearest tenth of a foot. We need to find this height. But for that, I need this piece first. This is an isosceles triangle, so I know that this is going to form 90-degree angles. We can use the Pythagorean theorem to find this length. Since the whole base is 16, this is cut in half. That means each one of these segments is 8. Just remember that the height is from the ground to the light. So subtract that value from the total height.